I'm going to review the quantitative problems on the take-home quiz from this past week. Problem 3, we have the following inverse demand equation and marginal cost equation. Part A of number 3 just asks us to find the profit maximizing output level and profit maximizing price. Let's take the inverse demand equation and convert it to a marginal revenue curve. Marginal revenue has a slope that is twice as steep as the inverse demand. In that case, the minus 400Q becomes minus 800Q. Marginal revenue equals marginal cost. Will give us the profit maximizing output. 800Q equals 2,000. Q equals 2.5. Profit maximizing output. To get the profit maximizing price, we'll take 2.5 and plug it into the inverse demand equation. Okay, and we get price equals 6,000 minus 1,000 or $5,000. That is part A. Part B, basically the same type of question. The only thing we're doing here is looking at the impact of an increase in marginal cost. And in this problem we're told that marginal costs now equal $4,400. So just redoing what we did in step 1, but this time setting marginal costs equal to 4,400. We're going to get 800Q equals 1,600, or Q equals 2. The profit maximizing price in this case is 6,000 minus 800. Or $5,200. And that is part B for question number 3. Okay, the next question on your take-home quiz, problem number 4, deals with price discrimination. Part A, we're going to solve this problem assuming the firm doesn't price discriminate. So what we need here is the total market demand, calculated by summing up the individual market demands. Total market demand in this case equals 34 minus 0.25p. When you're not price discriminating, the price is set the same in both markets, so P subscript 1 will equal P subscript 2. Just add up the P terms then. The inverse demand will solve dividing through by 0.25. Price equals 136 minus 4Q. Solving for marginal revenue, 136 minus 8Q. Setting marginal revenue equal to marginal cost. Marginal cost over here is just going to be 40. $136 minus 8Q equals the marginal cost of 40. 8Q doesn't look like a good Q. 8Q equals 96 or Q equals 12. So the firm wants to produce 12 units of output, and it will set a price of a 136 minus 48 or $88. So that's the answer to part A. Firm produces 12 units and sells each unit at $88 a piece. In part B, the firm is going to engage in price discrimination by setting the profit maximizing price based on the market demand conditions. In market 1, inverse demand was given as this. Solving for the inverse demand, the price in market 1 is 120 minus 5 times Q. Marginal revenue in market 1 then simply simplifies to 120 minus 10Q. Setting that equal to the marginal cost. Marginal cost is still the same, it's still 40. Oops. That looks terrible. 120 minus 10 times Q equals 40. 10Q equals 80. Q equals 8. Or Q equals 8. It's too early in the morning to do this. Q equals 8, and the price equals plugging 8 back in the inverse demand up here, 120 minus 5Q. Excuse me, 5Q. Like I said, it's too early in the morning to be doing this. Price equals $80. Okay. Let's try this now for market 2. The inverse demand in market 2 is given by 200 minus 20 times the output in market 2. Marginal revenue in market 2 is given by the following, and then we set that equal to marginal cost. Constant $40. And the output in market 2 is 4 units. I should have a subscript on here too. Sorry. Okay, and right there, right there, right there. Okay, market output in market 1 is 8. The output in market 2 is 4. The price, let me put a subscript there too. The price in market 2 is 200 minus 20 times 4, or $120. And we are done. Let me know if you have any questions.